Welcome to Schweitzer Drive, a podcast where we explore what goes on between the generation of electricity and the light switch. Join Dave Whitehead as he interviews the entrepreneurs, innovators, and experts who are inventing the future of electric power.
Hi, I'm Dave Whitehead. I'm the CEO at Schweitzer Engineering Laboratories, and today I'm going to be talking with Tony Lee, one of just 3 distinguished engineers at SEL. Tony joined SEL in 1991 and has served a variety of roles, including Principal Research Engineer, R&D Director of Transmission and Distribution, R&D Director of Power System, Vice President of Quality, Chief Manufacturing Officer, and Chief Research and Development Officer. You know, Tony, I like to make the joke is you've had a lot of jobs over your 30 years of working here, and it either you can't hold one or we just find something else for you to do that helps out the company.
Yeah, so after 19 years at the company, I counted and I'd had 18 titles. And of course, that was now 10 years ago, so I'm sure I've had probably 10 titles since then.
Well, with all those various titles, you had over 30 patents that you've come up with, and Tony's inventions are included in almost every product that we ship today. I'm really excited to be talking to Tony about essentially what makes a good product developer. We're going to talk about skills and how deep you are or how wide you are in your technical ability. So hi, Tony, and welcome to the show.
Thank you.
Tony, you're a prolific developer. You've led development of some of SEL's first, such as a self-powered relay, our first recloser control, our first line current differential relay, just to name a few. These products were all and are still very popular. It takes a lot of different talents to build successful products that protect power systems, including understanding power system fundamentals, hardware, mechanical, and software design, communication theory, marketing, sales, and many other skills. What is your story when it comes to being a successful product developer?
So I have a couple of bits of advice for folks who want to be a successful product developer. One is whatever your job is, do it better than anybody has ever done it. So it doesn't matter what task you're given. It doesn't matter what assignment you've been given. Do it the best, and pay attention to what's going on around you. And we'll talk a lot about, I think, paying attention to what's going on around you. When you and I were growing up in product development, we got to rub elbows with, some power engineers and with Ed and with manufacturing folks. And we got to see a lot and application engineers, folks that help the customers. We got to see a lot of the business. And so we were exposed to all of that. And I think it's a really valuable thing that we got to do. We got to see all of that and engage in the conversations and learn from all of those great folks. I think it was really, really powerful.
Tony uses the word got to. I think we had to.
Well, yeah, that also.
We were very small back then.
We certainly were expected to, yeah.
So let's discuss what makes a good product developer. You shared a recent article with me from the Harvard Business Review called "In R&D, Generalists Are More Valuable Than You Think." And for everybody listening, we'll post this on our website. How would you summarize the article?
So that article was written about sort of academic researchers, PhDs, scientist researchers, and their conclusion was that you need to have some generalists around, some folks that have wide knowledge or wide experience to sort of spur the specialists, to spur their ideas for innovation and maybe to guide them and help them. I don't know if it's focus or defocus, right? It's when a specialist works by themselves, they get too honed in on one aspect of something and sort of lose sight of the value of what it could bring.
That's interesting. You and I have talked. Maybe it's an observation, maybe it's actually happening, with this tendency towards increasing specialization in engineering over, say, let's call it the last decade. What do you think is driving that?
Man, I wish I knew exactly what it is. I'll bet it's more than one factor. I bet some of it is the technology. The technology becomes more and more complex, and it takes longer and longer to master any aspect. So you and I kind of were woken up to the fact that now what we call digital design, which is designing sort of the microprocessor part of the product, has become a really technical, special aspect. And it used to be pretty straightforward. You could do it pretty quickly, and you'd read a couple data sheets and figure out how to use the parts and connect the parts together, and that was about it. And now it takes months of detailed learning and understanding and study and interfacing with the vendor and working with your PCB designer to get that right. So part of it's technology. Part of it, I'm afraid, is that we are a bigger organization, and the folks that are doing those jobs don't have the opportunities that you and I had, or maybe the expectations that you and I had, to see the bigger picture, to understand what product they're working on, how does it work, what function does it do, why does the customer need it to do that function, what are the customer's sensitivities to various imperfections or non-ideal aspects of the thing. So I think it's probably more than just one thing, and I don't know exactly how those two combine to cause it, but I agree it's happening.
I'd agree with you, right? Things were probably simpler when we were hooking up data lines. We only had to hook up 32 data lines. Right now they hook up 64. There's probably 128 now, and that's just on a processor. Who knows what's happening with an FPGA these days? Lots and lots of lines. And yeah, it has been more. It's certainly probably more challenging than it was, say, a handful of years ago. So maybe it's a little bit harder. Would there be more? Is it more efficient to design a product when you have specialists then versus a generalist? You and I were generalists. We just did it all, right? But now you can have somebody, as you pointed out, do digital design or maybe analog design or something like that.
Yeah, it might be more efficient the first time. But I worry that that's a sort of a false economy. I worry that it's a short-term gain. I worry that if you just concentrate on efficiency, that long-term you're going to miss out on some really valuable things like innovation, like customer-facing innovation that could be coming from those folks. But because they never get a chance to understand what the customer needs or even what their customers need, that they miss out on that innovation. So and then the other thing is, I'm sure you're concerned about this too, is I think that's where leaders come from. I think leaders are almost by definition generalists. They do some of everything. They do many things very well, but a lot of things they can sort of hold their own in.
That's interesting. I guess maybe the thing is should I be concerned, or should we be concerned about specialization perhaps trumping generalist, or maybe it's the other way, generalists dominate specialists, and where do you see our industry in this one, not being necessarily power systems, but just product design or this innovation? Is there, do you think there's going to be a balance, or are we going to end up with more specialists and generalists, or vice versa?
I think we have to find a balance. We have to figure out how to give engineers, anybody early in their career, we have to figure out how to give them the opportunity to at least see what's going on around them, to appreciate it, and maybe even to participate in it. Everybody's got some upstream supplier for what they're working on, and everybody's got some downstream customer. Those are the two most obvious opportunities they have to see what's going on around them, and they certainly must take advantage of that. And then if they decide, after they look out at, hey, I looked at what it's like to design a part of a relay, and I looked at what it's designed. If you're a firmware engineer, I looked at what it's like to write RTL, and I looked at what it's like to design a circuit, and they decide all they want to do is specialize in some aspect of firmware engineering for the rest of their career. That's okay. That being a specialist, that's admirable. But we have to give them the opportunity so they can make that decision. Otherwise, it's being made for them.
So here's an interesting question then. From an organizational standpoint, should we rely on natural selection for people to either specialize or be generalist, or should there be a company objective or some more guidance, I guess, in directing people's career and maybe an emphasis on one or the other?
I think you could do it either way, and you could do it both ways. Certainly for us, it was expected. We were expected to look at what the power engineer was doing and understand how those elements work so that we know how to design the product and how to test the product properly. We could set that expectation and maybe even enforce it. But at least we have to give them the opportunity.
Do you think us or other companies do that, encourage that, or is there an emphasis for folks, maybe consciously or subconsciously, to specialize? I mean, we already distinguish between a hardware engineer and a software engineer, or a power engineer or something. And are we just taking it one more step? You're an RTL engineer. You're not a firmware engineer.
Yeah, that's right. I forgot until right now that when you and I hired into SEL, we all had the same title, whether you were doing firmware or electronics or you were a power engineer, you were called a development engineer. And I think sometimes Ed thought we were developmental engineers, but
we were certainly challenged.
So maybe he did that on purpose. Maybe that was intentional to set the expectation that we all had the expectation to learn the entire instrument. I don't know.
I bet you're right. At least on some level, I think we had him as the president. The rest of us were developers, right? That was certainly a lot of fun. One of the challenges for companies like SEL is to ensure that we have a depth of bench when it comes to leadership, and this is sort of what we were talking about a little bit earlier. Has this increasing specialization, our on process or technology or management style, caused us to miss out on identifying and developing good leaders?
I'm afraid it has. I'm afraid that there are really sharp folks out there that could be outstanding leaders, and we never see them because they're hidden inside of a discipline. They're really good at electronics design, or really good at writing programmable logic, or they're really good at writing firmware, and we never get exposed to them because they haven't taken advantage of the opportunity, or they haven't seen the opportunity or recognized the opportunity to become involved in that bigger discussion about how the product should perform, what it should do, how can we take care of customers. I think you and I were probably in front of customers in the first calendar year of our employment at SEL.
I was in the first week. I started the week of WPRC and got sent up there and had to explain to a customer what this blue box did. And I can tell you that was a resistor and a microprocessor on it, but that was about it.
Yeah, same with me. I hired in July, and in that October I was at WPRC explaining to experienced protection engineers how a relay works.
Yeah.
So it was quite different, and I don't know how we could give that sort of opportunity to every electronics engineer that we hire, but we have to find some way to at least entice them into taking an interest, or maybe, like you said, demand that they take an interest in how the product.
That was going to be my follow-on question. So if we're not able to see some of these younger career folks now, what might we do? Is it us as an organization, or anybody to get some visibility? Organizations continue to grow. When we started, I was in the employee in the hundreds kind of stuff. I'm sure you were sub 100. Now we're 5,200 people around the world. And how do you be a small company within a big company? Or
yeah, that's a challenge, and of course it has to do with leadership and organization, and things that executives and managers drive. Certainly, we can't lay all that at the feet of the engineers, although they have some responsibility in it also to lift up their head and look around and see what's going on, and understand the business and the company and the industry and the customer. All of those things are. That's what I mean when I say generalist, by the way, is that you begin to get an understanding of all of those.
Yeah, we were talking a little bit too about specialist versus generalist, and I think people might come away with the impression that a specialist is very, very narrow, but very, very deep on a particular subject, while a generalist is very, very wide on just about everything, but very, very shallow on it. Say a mile wide and an inch deep is what folks say at times. And you and I were talking, and I was reviewing your career with you. That's a kind way to say it. Is that Tony started off as a hardware specialist, and then he became a software specialist, and then a power system expert specialist, right? And so it wasn't necessarily that Tony was, or now is, a mile wide and 1 inch deep. He is a mile wide and 10 miles deep on each one of those particular subjects. And perhaps that's lost on people too, that a generalist is not, they may be able to spell FPGA, rather they really understand how to apply one and build one.
Yeah, and I think that goes back to that advice. No matter what assignment you're given, be the best at it, be the expert, and then you're going to be given another assignment. Then go be the expert at that, and before you know it, you've been given 10 assignments, and you're expert in 10 different things, or at least 10 aspects of a thing, and that's part of it. It's not a veneer thickness understanding. You have to have some depth also, for sure.
So if you're putting together a project team now, see, Tony, go build the next relay or whatever it might be, how would you go about staffing a project these days? What would you look for in terms of a balance between specialists or generalists, or maybe neither?
You know, it's challenging. I know a few generalists, but they're not that many, and they're in high demand. And so you try to figure out how to recruit or entice or get them onto your team, and they're in high demand. So my advice to folks doing that would be to find some smart folks and get them to be interested in the big picture, and how the device operates and how it's used and how the company operates and how the industry operates.
I know you are one of those folks, especially when you're doing product development every day. We'd say, Tony, go build a line current differential relay, right? And it's Tony's first response is, I don't know anything about communication. I don't know anything. There's a whole list of I don't know any. And then, a week later, Tony had read a book on this or done this and did some experiments or something like that. Do you find that kind of folks these days? I'm sure the answer is, yeah, there are a handful of people who will say yes without realizing how hard something might be to pull off, right? And are we seeing more of that or less of that, or is it just easier to specialize these days?
It might be easier to specialize, and I'm afraid we're seeing less of it. But there are some folks out there that with that grit, right?
Grit is a good word.
With it, you ask them to do something, and they're like, I don't know how to do that, but I'm going to go figure it out. No, I don't want you to take this from me and give it to some specialist. I'm going to learn this, and I'm going to figure it out. And that's a special kind. Well, it's not a special kind, but I fear that it's increasingly rare. I fear that it's too easy to say, hey, I didn't expect this problem, and I'm not an expert in this problem. So I want you, management, or you, my lead, to go find someone to solve this problem who has experience solving this problem. Instead of, I'll Google it and I'll find a book and I'll learn it, and I'll learn it enough to solve the problem.
Yeah, I've found there's a few different types of developer personalities. There is one that will always tell you can never ever be built, right? And you never want to have those folks on your team. Then there's the other type of that is, hey, we can get this done. And within that group there is we can get this done, but let me tell you all the problems we're going to run into, right? And so they know we can, but they're kind of that doggy downer kind of person, because they're going to tell you all the. And then you have the total opposite of that. It is like, how hard could this be? Yeah, let's go do that. Recognizing, there's probably going to be some problems, but let's just go tackle the problem anyway. And I know working with you, it's all right, yeah, we're going to run into problems. Let's just go run into them now versus trying to figure out what all the problems may be in the future.
You can't run into a problem if you never start. You can't fix the problem if you never run into it. So I do learn more from failure than from success, though. My failures are burned into my brain, and I know what caused them. And they're that's another great thing about the thing we got to do, is we got to fail at a lot of different things, or at least try a second time at a lot of different things, I guess.
We does it right because we does it twice, right? It's maybe the saying as it goes. But I think you're right? When it comes to all the products that we've had the opportunity to work on, not everything went right as planned. And I can remember all of the, let's call them the failures or the challenges, right? And those represent probably 2% of the entire project, 3% maybe, right? You did 97%, 98% of the things absolutely right. And it's like, I don't remember any of that stuff. I can remember that one day we had that one problem. It's like, how did I miss that in a design?
And I was here at 2 a.m.
Yep.
trying to figure out.
Before Tony or my boss figured it out, right? I can fix this in the before they get here in the morning.
I told Ed I could make this work. Now it's 2 a.m. I better make it work.
Yeah, exactly. Because he'll be in at 7 o'clock in the morning asking how things are going. Or 5, yeah. All right. Where do you fit in on the scale of specialist versus jack of all trades? And how do you think that's affected your career?
I think I am, like I said, it's kind of relative. And I think we discussed this before we started recording, but I think it's kind of relative. Among product developers, I think they see me as more of a generalist. I'm not an expert, a deep expert in much, in maybe just a couple areas. And so they see me as a generalist. But among the executive team, I'm probably kind of a specialist. I do protective relay development. That's my background. That's what I spent most of my career thinking about. I did some manufacturing and some quality, but most of my career has been spent developing relays. And then compared to Ed, I'm very narrow. I'm a super specialist. I'm a product developer, right? Or maybe a problem solver or whatever. So it's relative, but I consider myself to be more of a generalist. And then the second part of the question, how do I think it's impacted my career? I don't know if it's being a generalist that's impacted my career or just never saying no to an assignment that has impacted my career, and that's how you get to be a generalist. But I've enjoyed it. I can't imagine doing the same thing that I started doing 25, 30 years ago. I can't imagine still doing that today. It's, and just getting better at that one thing and getting deeper and deeper.
Well, I think we've been fortunate to see a lot of different kinds of product development. And maybe to your point, it is, hey, I want to do that. You see somebody having some fun. I'd like to try that, right? And you go and try it.
Yeah, I remember when in about 2000, you've talked about line current differential relays a couple of times. We started developing that first line current differential relay, the 311L. And I signed up to do a couple of tasks on that project and to lead the project as a whole. And at the time, this discipline called RTL or VHTL author didn't exist at SEL. We'd never done it before. And at about the same time, I think you were working on the 421. I was working on the 311L. We both decided to put FPGAs on our products. And well, there's nobody to do it, so I had to do it. So I taught myself how to, or actually, I learned from Zweigel, Craig Zweigel, how to write FPGAs or how to write VHDL.
Yeah, but how hard could it be? We had able, right? We were just extending it. There's a colon equals something, right? Yeah. Syntax.
Yeah, and so you just don't say no. You just don't back down.
Well, that's a good thing. Talking about generalists and specialists is one might make an argument RTL is nothing but a variant on, say, C or some programming language, right, where you can code things up. Of course, what we're doing is building hardware when we write VHDL, and then there's that hardware component. Really, if you're writing VHDL, you want to understand state machines and how to build things, which I haven't taken a computer science course lately, but certainly in hardware engineering, we learned about state machines and stuff like that. So it's this blending of technology. I think probably gave you you understood software, you understood state machines and hardware and how to design that stuff, bringing that together. The perfect one to bring in RTL into the company. Yeah,
so I think the magic blend there is you gotta not be afraid of the high level language, which VHDL is a high level language, and you gotta not be afraid of this thing called programmable logic, this hardware that you're programming. But in my mind, I had to be thinking about the hardware I was building all the time when I was writing that code.
Well, in the fun part about RTL, well, now we're getting into techie talk, which is great because we can do anything we want to on this podcast. Is I can always remember the first time I was writing RTL too, and it's a different experience talking about generalists and specialists. Is when you're programming in RTL, you got to think in 3 dimensions or more, right? Because everything's happening all at the same time, as opposed to like code that's just executing one line. You got a lot of things going, flip-flops firing off everywhere and trying to synchronize everything. It took me about 3 days to get in the zone to write RTL.
Yeah, I remember first coming to that realization that, hey, all this code that I'm writing, every line of code is going to execute every clock cycle.
Yeah.
And that really set me back, and I had to rethink. Okay, now I got to rethink what I'm doing here because that's just not normal.
And that's what we got. Greg Zweigel's one rule, right? There's one clock, one God, right? And that's how you build RTL at SEL. Hey, maybe one point of clarification for our younger folks that are specialists, perhaps being generalists. You brought up that, hey, if you're sitting around the executive table, you're no Joey necessarily. You're no CFO or pick somebody else, right? So in those sitting around that table, you're a specialist. But I'd almost remind myself that when you're at that level, nobody's going to, maybe Ed is going to be a generalist, right? And that's how everybody leans on each other for Joey to come in as a CFO or Tony as the chief R&D officer to bring these collective ideas and perspectives. Because at some point, unless you're this really, really unique individual, you're never going to have all those skills. But certainly in your early career, being a developer, I think the generalist approach or career development is probably going to serve you well if you want to advance through a company or a corporation.
Yeah, I agree. We have a dual career ladder here at SEL, one that's technical and one that's managerial, and you and I have been on both and hop back and forth between the two ladders. You could stay on the technical career ladder your entire career and be perfectly technical and be a really top-notch engineer, and we pay them really well, and we reward them for their contribution, and or you can go up to manager level and be manager and director and vice president and chief, and they're both valuable. They are.
Yep.
But I think that even the folks that progress the fastest through the technical ladder are more generalists. They're more technical generalists.
And I think that was an aha moment to me too. We've been thinking about this for the last handful of weeks. It is, you think the specialists are the ones that are perhaps going to drive a lot of innovation and things, and they are certainly part of the equation. But it's these generalists taking ideas from all kinds of different disciplines and different kinds of technologies, rolling them up together. And I think that's where you have your big innovative leaps of product development.
Yep, I agree. Every innovation, every invention I can think of, I was thinking about how to solve a problem for a customer. It was never a problem I was having or a problem I was seeing around me. It was a problem that I became aware of some customer was having. And I can't imagine doing innovation any other way. I can tell you that when I was not thinking about the customer, I would come up with innovative ways to do my job better. I would come up with innovative ways to make the process more efficient or faster, but that's not customer-facing innovation. That's not what SEL gets paid for. That makes us more efficient and faster, and that's all good from the customer's perspective. But we get paid for customer-facing innovation.
Yep, I agree. Well, Tony, it's been a lot of fun. I do want to ask you, and covered just a little bit, but you've had 30 years, just a brilliant career in creating products and coming up with new inventions and new solutions. What pieces of advice would you give to this? I just graduated last month. What advice would you give somebody starting their career?
So there's two pieces of advice, and we've already talked about both of them, I think. One is do whatever task you're given, do it better than it's ever done. Be the best at that anyone has ever been. And then do the same thing on the next task and the next task and the next task, and you will get recognized. And then the other one is don't turn down assignments. If somebody, especially don't turn down an assignment because you think you're not ready for it. If somebody asks you to do something and you're thinking in your head, I don't know how to do that. Well, yeah, you don't know how to do it yet. Go figure it out. Somebody's going to pay you to learn to do something. What could get better in life than to get paid to learn? I just don't know.
That is, I especially like that last piece of advice. There is, you may not think you're ready for whatever task you are being asked to do, but the person asking you believes in you that you can do it. And since they're asking you, they're going to support you to do it. It's win-win, right? You're going to learn something new, have a lot of fun, probably skin your knees a little bit doing it, but there's no better way to broaden your career.
I agree.
Thank you, Tony. This was a fun conversation.
My pleasure. Thank you very much for having me, Dave.
Thank you for stopping by Schweitzer Drive. Join us again as we learn about, explore, and celebrate electric power. For more information about the show, please visit selinc.com/Schweitzer Drive.